Hi everyone. This is our final installment for the vegetable production course, mushrooms. I'm really disappointed you guys didn't get to see the mushroom farm in Leamington, but Highline mushrooms, worth applying if they have a job. I don't know right now what's going on, but worth looking into. Let's dig into it a little bit. What is mushroom production? Um, right off the bat, we're talking about just the life cycle of a fungus, right? So let's start with spores, and they're going to combine. There's two chromosomal components will combine. They're both haploid. They form a diploid, sporangium or sporangia that will eventually form into a fruiting body, which then releases spores and the process starts again. So most of the time, what we're talking about here is the process of inoculating with the mycelium, which is usually purchased or grown in a lab if you're a big company. You inoculate this into your compost, and it infiltrates through the entire compost and eventually starts producing the fruiting bodies, which then you harvest. So compost is a huge part of the mushroom process. It's actually, I would say, more than half the work in making a mushroom crop. So the art is in the compost. Um, there's actually a lot of crazy ingredients in mushroom compost. I'm just giving you a basic upfront look at it. Straw, sometimes corn cobs, which is a waste product from fields, even cottonseed meal, depending on where your farm's located relative to cottonseed. So maybe in the southern states. Manure, specifically straw bedded horse manure, seems to be the best base to start with. Um, and then often we have to add nitrogen. Um, Chicken manure is common. Sometimes just ammonium nitrate or urea is added. And then gypsum, which is calcium sulfate, is added to raise the pH because of the composting process makes it quite acidic, and it also provides calcium, which helps the mycelium form properly. Um, Lots of straw. This is a major ingredient in the process. This is just a diagram I snagged off a fancy government document that talks about the process. So we have our bulk ingredients, our nitrogen supplements, our gypsum, which goes together to form the substrate, and then it begins to compost. And as it composts, there's leachate, which is collected actually and reused to inoculate the bacteria in a continuous cycle. This is always recycled. And then ultimately, you have your mushroom compost. So typically, farms have a large pit or pond where they use heavy machinery to dunk bales into a bacterium soup. They're often very proud of their soup. It stinks. It's pretty gross. They'll dip the bale in long enough that the liquid can infiltrate into the entire bale and get all the bacteria into it. And then that begins the composting process of breaking down the straw. Like I said, the leach is collected and put into a pond for recirculation and reuse again. You'll notice it's aerated. We want aerobic bacteria, not anaerobic bacteria in this process. We want to keep the nitrogen in the compost because the fungi need it. If we let it go anaerobic, that's going to consume the nitrogen and release it as nitrogen gas. Um, so at this early stage, we mix in our manure, our gypsum, all our different ingredients into that inoculated straw. And it begins to get hot, right? This is just like plant science too. We're talking composting, right? So it starts to compost. Sometimes they have indoor windrows where there's a machine that blends and mixes the compost to keep it aerobic as it begins to compost and break down that straw. Um, Typically, sorry, figures my phone rings. Um, it is then moved into these large rooms. They're called finishing rooms. Uh, they clean them between runs. There's a person here sweeping the floor. There's usually slots in the floor so they can blow air through the compost to keep it oxygenated in the room. In those rooms, we try to achieve the highest possible temperature, and oftentimes steam is applied towards the end to sterilize it when the composting is done. We want it to be sterile because when we inoculate a fungus into the compost, we only want that fungus to grow. So it has to be sterile. Uh, Once it's sterilized, cooled, it's brought out and loaded into the grow rooms. Typically, that's done on the back side of a grow room. They have a truck that on one side is delivering compost. You can see it behind there. And then there's another truck over here that's delivering a special layer of heavy composted peat moss. That's typically called a casing. Here's a picture of the compost being dished out and the casing that's being laid on top of it. Casing is generally added to maintain the moisture levels in the compost once it's in the grow room. After this, so you're transferring in, think of it as it being sort of dished out as a thin layer via conveyor into the room and having a casing layer put on top. And as that's being done, the spawn or the mycelium is being added to the composting layer below the casing, and that begins to seed the growth. Spawn is typically grain, barley, or wheat that has the spores and hyphae growing on the surface, and they feed slowly on the grain seed. That's how you keep it alive. Here's a picture. You can see the casing on top, the compost below, and ultimately you see the layers here, right? There's your compost, and then there's your spawn layer, and then there's your casing layer, which is trapping the moisture inside to keep it constant. We can add water to the compost to keep it moist up until the point where the mushrooms begin to form. Then we can't add water anymore. So the casing is really critical in maintaining that moisture level. Plus the mycelium prefer to grow in the dark below the surface, and then they want to push through a surface to be able to produce a fruiting body. So this casing plays a pretty important role. There's a lot of companies out there selling different types of machinery that automates the laying down of the casing on top of the compost as it's put into these long benches. So here you see a picture of a bench in the grow room. You can see the dark casing and mycelium starting to show through the surface. Got a picture zooming in on the hyphae as they're protruding. In these rooms, typically it's dark, humid, fairly warm, and we want really high CO2 levels. So typically the grower stays in a room a very short time. They're not going to spend a lot of time in there because you could go unconscious. Anything over 5,000 ppm, humans start to get a little dizzy. So at this point, we're just growing the hyphae, the mycelium into a dense network. Keep in mind that mushrooms are feeding on the compost. We put all that effort into the compost for a reason, right? They're feeding on the calcium, the nitrogen, the carbon that's in the straw fibers. And they, of course, are producing carbon dioxide. So those high CO2 levels are achieved just by closing the door and letting the mushrooms do their work. Once we start to see mushrooms forming, we need to control the CO2 levels a little more precisely. Ideally, anywhere from 800 to 1500 ppm CO2 is ideal for most mushrooms, or the classic ones you see at the grocery store. It's up to the grower to maintain these conditions to maintain productivity and high quality, so the mushrooms are all able to be used. So looking at anything less than 800 ppm, we end up with really tiny mushrooms and lots of them, which of course is no good to anyone. So that's a job poorly done. If we go above 2,000 ppms, we get poor quality mushrooms. They begin tall with very small mushroom heads, and that's not what the grocery stores and the consumer are looking for. If we go even higher to say more than 4,000 ppms, we actually get reduction of growth. It slows down. There actually are times when this is useful. Mushrooms are funny in that if we let them form too quickly, the mushrooms bump up against each other and they get misshapen heads, which ends up being a B grade. So the grower has to sort of throttle the growth of the mushrooms so that the harvesters can keep up with it, and you have kind of a nice consistent yield coming out of the room. If you let them flush all at once, they actually jam into each other and become kind of square and flat on sides, and consumers don't like that. I mean, again, it's not that the farmers care, consumers don't like it. So the growers are really monitoring things like temperature, humidity, and quite a bit the CO2 levels to maintain consistent high quality productivity. If for some reason you need to regrow your base, if there's been a major problem and you want to regrow your hyphae, you just let the CO2 levels climb above 5,000 ppms. Your mushroom production will stop and you'll get lots of mycelium growth again, and then you can reflush the room to produce more mushrooms. So again, careful control of CO2 is essential for mushroom production at this final stage. And we control it by basically just exhausting the room, right? Remember, the mushrooms are producing the carbon dioxide. If we close the doors and don't exhaust, the CO2 levels will just continue to increase. And if we need to lower it, we just turn an exhaust fan on and it vents the air out, brings in fresh air, and that lowers the CO2. So typically an Argus computer or some sort of climate computer is used by the growers to modulate the rooms for productivity reasons. After about 3 weeks, once you've laid your bed, inoculated the mycelium, mushrooms start producing. It's pretty quick. And you can harvest, they just pick the buttons. This room is actually flushing a little too rapidly. There's too many mushrooms in there. Either the harvesters have fallen behind or the grower let too much form at once, but that's fine. You can see what they look like. There is two modes of harvest. There's human harvest for your classic buttons, and then there's slice harvest. Slicing basically is a machine that slides back and forth across the table and chops off the mushrooms as they go above a certain height. Mushrooms will continue to grow between the gaps and form again. It'll keep slicing them off. Obviously, this is a lower grade, lower value, but you have way less labor. So sliced mushrooms versus buttons. There you go. This link will take you to a video showing how that just zips along, slicing them off. It's pretty satisfying to watch. For those of you who are interested, there are other ways of growing mushrooms, but these are usually not commercial scale. These are niche methods. Some of you might even want to consider growing mushrooms. Maybe some of you already have. These are oyster mushrooms that are grown in bags. They're often grown in rice husks, not compost. And so the mycelium is inoculated into the rice husks, which are bake sterilized. And then slots are cut in the bag, and the fruiting bodies will pop out the slots, producing these clusters of oyster mushrooms that you just snap off, and they'll regrow again for quite a few cycles until the spawn slows down or the quality drops, and then you just drop the bag and put a new one up. These are some links for you to look at if you want to watch the process in a little more detail. The last one's got some funky old music, lower quality video, but I like this one the best if you want to get a better sense of what this process looks like.